Okay, my name is Slava, and this is yet another talk about akka-persistence. Oleg in his talk, Casino talk, covered the first year of such a project, and I would like to cover what happens next. Can I ask to raise your hands who has who doesn't know what event sourcing is? Okay, a couple of people. I will try to say a couple of words of this, but that's not an introductory talk. That's neither a technical talk. So if you will have less knowledge than you expect, sorry for that. May I ask now, raise your hands, who has already akka-persistence in production? What are you doing here? Guys, I will not tell anything new to you. That's just my experiences over the 1 year of having this in production. So maybe it's time to switch the room. Okay, one last question, or what I would ask you to do. I tend to speak faster and faster during the talk, so just raise your hand and interrupt me if I do and ask some questions, like we just trained. Okay, so akka-persistence. I myself started to use akka at about 2011. And at this time we had Java 2.7, and it was an interesting time. It was akka1.x. I actually had to look up the exact version on the akka website. You probably cannot read it, but it starts at 2012 with akka1.3. So actually I started to use it 2 years before it started, like 2 years before Christ. And indeed, it was not yet akka.io, it was SE, Scalable Solutions akka. And it was beautiful time. So those projects were very special in the sense they all were greenfield projects. We had absolutely freedom, amazing technologies, which weren't exactly amazing at this time as compared to the state which we have currently, but they were amazing compared to the state which we had in Java those days. So for example, the first book on akka was this effective akka book, and it came out in 2013. Like we had 2 years of experiencing Scala before the first book about it came out. Or imagine yourself this kind of job description. I don't know, can you read this? Okay, like 8 years of object-oriented programming language experience, 8 years Java Spring experience. Yeah, let's talk about that. Yeah, unimaginable. Okay, so that was beautiful time, and this project was similar 2 years ago, and I joined it 1 year ago. And people made some decisions for us, and we had to live with those decisions. And it wasn't exactly as easy as you can imagine, because this was an event sourcing project and akka-persistence project. So to describe, to give you an overview, that's what we did. So we had a customer which would have workers, and the workers would work on site where they had no connectivity to the internet. And because of this, they needed to call back office and ask people to enter data into the Microsoft CRM. Or if there was no mobile connection at all, they needed to write it down on paper and then to go to the office and put it in. So it wasn't very productive. The idea was to give them a mobile application, and the mobile application would be offline first. Offline first means users can use it offline whenever they want, and the application would store their actions. After the user will become online, the application will replay or revert those actions depending on current state. It would convert CRM changes back to actions from another side, and it would apply to those actions to the current state to modify it. So there is a Redux plugin for for React.js, and it does exactly this. So it collects user actions, it throws them on the reducer, reducers modifies internal state, and the changes are reflected in the UI. And this approach of collecting actions or changes in small increments and modifying the state and storing the actions but not the current state in persistent store is called event sourcing. Basically, that's very easy. So user actions are commands. Those commands can be valid or invalid, or so that they can be accepted or discarded for whatever reasons. The CRM changes in our case would be command but coming from another side. And they would be then applied, converted to events, applied, and they form the current state. That's event sourcing. So for those who don't know what it is, very easy. The key moment you have events, all what happened with your system is in the storage, but you don't have current state. But the Microsoft CRM runs in Azure, so it was crap. It wasn't reliable at all. So basically, we could not build a mobile application which would be able to use Microsoft CRM directly in production. So we introduced akka backend, which basically would act as a middleware. So it would collect the changes from the mobile app and it would push it to the CRM and vice versa. And naturally, the architecture of this middleware would be the same. So the commands in the backend would be the changes in the mobile app. They would be converted to the events, they would be stored in journal, they would modify the internal state or the view how it looks for the client. And the view basically consists of actions or of events, how they should be applied on the side of the client. And on the other side here, we have commands which are basically encapsulate changes from the CRM. Same structure. And obviously, there is a framework for this, akka-persistence. Yeah, I know, no intrigue here. It was in the title. It was easy to start. So, like, currently you can use only single dependency. You throw it in, you have actors, you have persistence, you can build your app. You can deploy it into production. You can let it run for some time. And it was our case. So basically, we had this application run in Microsoft Azure for the previous team, like for a year, and we for a couple of months. And then we migrated this to AWS. Bam. So that's what we experienced immediately after the migration. Our journal was corrupt. And the reason for this is, like, if you can see, I hope you can see, we had duplicate entries in our journal. And the reason for this was, like, the load balancing works differently in Azure and AWS. So in AWS, first new instance is started, it loads its internal state. The load balancer waits until it becomes healthy, then it kills the previous instance. And basically we had two instances running in parallel. But persistent actor is a global singleton in akka terms. It means there should be only once, like Highlander. And because it's a global singleton, the persistence ID has to be unique. So you cannot have two persistent actors running in the same time in akka-persistence. Because of this, we had suddenly downtime during deployment because we needed to reconfigure our load balancer to first kill the old running instance and then to start new instance. Or as an alternative, we could use cluster sharding. We didn't because we don't care about our users. But yeah, for the case if we would, it's easier. So cluster sharding is basically, sorry for that, is basically you throw two additional dependencies. And technically, you could just use cluster with cluster singleton, which would make sure that you have only single actor running in the cluster. But this makes scalability and reloading actors to another machine hard. So that's where sharding comes in play. And it allows you move load across cluster and has such benefits like passivation. So it's good. Said that we don't use it. So basically, this single dependency is a bit of a lie of an akka team. I would say the akka team should put a huge warning at the starting time. So are you sure this is yet another pet project of you? Or do you want to put those in your build SBT and use them? Yeah, that was the first realization. Let's go back to our schema. So we now have our commands arriving. We have our events converted from those commands. Not each command results in a single event, maybe kind of multiple events for single command or none. But then they need to land in the journal. And first of all, we need to have some representation for this. where we come to serialization topic. There are different kind of ways to serialize and class into something which you can store. The most obvious and default and most dangerous is Java serialization. It's dangerous because it has binary compatibilities with Scala issues. It's actually prone to attacks, and additionally, it has a huge footprint, and it will break if you don't use it carefully. So I don't know why it's default, but it is. There are a couple of binary protocols, and there is a JSON, which is in our case was spray JSON. Actually, Oleg in his talk also said that they use JSON, and I guess there are a couple of reasons for that, and they all kind of caused by a very single basic cause, which is if you're doing your first akka-persistent projects, then it's highly unlikely that you ever did some event sourcing projects before in other language. So you have a huge cognitive load learning all this new stuff. And if you have additionally to learn binary protocols, it just adds this cognitive load, and developers just try to avoid it. And you can just like throw those two additional dependencies. One would be probably which you have anyways if you're using REST. Another one would be to connect the akka-persistence and the JSON format. And in the code, it looks like that. So you basically define very specifically how your case class is looking here. So you have two fields. Don't treat the rest, it's the same. So you have to do this over and over and over again. Yeah, but it works. Then you have to specify persisters for your representation. And you have to do this manually. And you, oops, what is it? Yeah, you have to do this manually, and you have to name them. And after you did that, you need to enlist them individually. And you need to extend the Stamina Akka serializer class, and you need to configure the Akka persistence to use it, which is kind of, yeah, very easy. So now we have something we can serialize, but as we were busy to serializing stuff, we had our sales department coming up with new use cases. Actually, who here has a sales department? Who likes them? Yeah, okay, so they were very active, very creative, very energetic, and pushed hundreds of new use cases on us. Which brings us to the case that we need to actually introduce new case classes for our events again and again and again, and we need to configure them manually. It's kind of stupid thing to do, especially the compiler knows how many fields do we have in our case classes. So there is a library for that, and it's based on shapeless, and it let us do following. So basically, we now could define just a single implicit for the whole family, for the whole family of related events, like for algebraic, for single algebraic data type. All are here presented by this single line. The rest, like connection via the persisters API, is the same, but we greatly improved on this manual work. Nice. We started to actively use it. We realized our compile times changed. And I actually built this slide bottom up just by checking out previous versions of the system. And yeah, the reason for this is like, this is a description taken from the GitHub of this library directly from the ticket. Basically, compile times really depend on your structure. And you have a choice to do something with that or not to do anything with that. We started to restructure our data to make shapeless happy, which kind of defeats the purpose. We're thinking about using macros for that. So yeah, the problem is not solved. And if anybody can after the talk approach me and say how it can be solved, it will be really appreciated. Yeah, so we now automated how we serialize stuff. But at this time, the sales, they kind of started to modify existing use cases because they run out of the new use cases. So what to do? And that's actually an interesting problem, because I asked Oleg in his Flipcoin example he was talking about. It's just an easy example, Flipcoin, but it's binary. He had 11 events for this simple use case. So in our case, it wouldn't be kind of exaggerating to say we had very, very quick dozens, hundreds, almost thousands of them. So we needed to do something with them, and yeah, actually we needed to change them. What could we do? First of all, you can just literally create version 2, version 3, version 4, and so on of the case classes in your code, similar to commands. Commands are special because they are not persistent, but that's separate topic. So, but then you need to define your logic for each and every separate version, or you need to at least take them into account. And then we're coming back to the shapeless automatic derivation, which I kind of 1 hour is long, but a couple of days would be not even longer for compilation. Yeah, binary formats, they offer a real advantage in the terms that some migrations are free, literally free. You just change the format and you're good to go. Other changes are not possible at all. And rewriting journal or deleting events would be another solution, but it's kind of, it's forbidden in event sourcing world. So the Stamina I've been talking about offers a solution for this as well. So it's versioning on the JSON level. What's happening here? We have 4 different versions, and each version has a modification applied on it. The modification here, each modification, they apply it sequentially, and they are applied on JSON tree before it is converted to the case classes. And in this way, you can modify the representation of the JSON, and it can be safely converted to only one single version of the event you currently have. Yeah. By the way, this is another one good example. This is a bad decision. Decision, is it? Yeah, this is a bad decision here, regardless what you do. You can decide, okay, I have this nested form in a couple of events, so I want to really incorporate this one time, have a single JSON serializer for this. But then if this form is changing, then you need to change every single event. You can say, okay, I will represent these separate fields, each separate field separately. Then you will only need to change a couple of events, handful of events, but you will have a lot more single events. Like if your form has 10 or 20 fields, then you will have 10 or 20 events instead of a single form event. And then it goes like this. So basically, you can say, you can modify those on the fly and then apply them. And this is a single modification. So here, you can see we have a couple of modifications. Each one is non-trivial. And multiply this by dozens, hundreds, thousands of events. Just imagine which code base this builds up to. But that's kind of the state, how you do the event sourcing. That's not specific to akka-persistence, actually. And then we have Scrum sprints. And each Scrum sprint is short-sighted. We just focus on what comes up next. We don't think about what will be here in 2, 3, 4, 5 weeks. Just every week, we build up some functionality. Bam. Okay. But yeah, that's us. We can somehow optimize on this. Try to optimize on this. Each single third-party dependency you will be having. If you let their internal implementation or their representation to leak in your events, you will need to change your event structure every time they change something. And it doesn't matter if those events describe outgoing changes or ingoing changes. That's just will be in your system. It's kind of, in a way, it's like a social network. Regardless what you do, regardless what you say, who you like, it's recorded there forever, and you have to live with this. Your refactorings, your all this stuff, I won't read it. That's just in there. Some libraries help you deal with that. Some make things worse, but that's how event-sourced system evolves. It's like literally like a fridge in the office. The deeper you dig in, the more stuff you can find which doesn't belong anywhere. People are long left, but this is here. And it's not exactly eatable. Yeah, let's maybe some questions? Okay, let's go back to our nice picture. So we now have versioned events. We're ready to store them. We have to use persistent storage for this. There are a couple of them, different flavors. We had to use many others, specifically MySQL, and the reason was we had to run on Azure, and we actually didn't have exact requirements to justify use something more powerful like Cassandra or similar. So it's nice. You have table for the journal, which is basically a key, a tag, and the message which contains your event. A key, a tag, and the message. And you have another table for snapshots, which is kind of the same. So much for the journal. I will return to those tables. That's why I wanted to show them to you, so that you kind of aware that they exist. So we have stuff in our journal. We can start to recover from it. And this is where the first realization comes. So I was very naive as I started to work on this project. I was just thinking, okay, akka-persistence should be something. I start the system, and it just runs at some point with the state, like it was before crash or before shutdown. That's not exactly the case. You, as a developer, has to make it sure that it restores to the state where it was. And this is mainly connected to the obvious fact, actually, if you think about that you first need to have an actor, and then this actor will read from the journal and recover its state. So there is no some magic which would create your actor for you just because there is something in the journal. Yeah, and because of this, you kind of have to have aggregate routes which would start this recovery process and create actors as needed. You need to have other persistent actors, like if you have services or whatever. And this makes the supervision even more stricter as it usually in Akka. So it's very explicit. You see actors saying, hey, my child. Yes, my parent. Yeah. And depending on number of events, it's very time and memory consuming. So if you have millions of them, if you have dozens of millions of them, and the bottleneck is not necessarily the database or the application, you can configure how many parallel actors will be recovered in parallel. But the network, the database, it all kind of, altogether, it's really long. And for some reason, I know, the MySQL has a specifically, some specifics to the recovery, which means we had to assign 16 gigabytes to our instances because MySQL keeps in memory everything which was kind of coming from the database until the recovery is complete. Don't know why. We weren't able to find out. We actually haven't looked because 16 gigabytes in AWS. What is it? So, and that's our customers, our users. They are waiting for recovery because it doesn't matter what they do until the recovery is complete. All their messages, akka messages, they will be stashed. So there's no point to accept requests from them because we won't be able to serve them. And additionally, if for some reason, and for some reason we had this case, we had the timeout as a part of the protocol. If there is a timeout, this means something is not existing, doesn't exist. And this led to the situation where we would accept user request before the system recovered, and this would lead to creation of some duplicate entries in the internal state. Like duplicate user is not exactly very good for the user, and it's unpredictable. There is a solution for that, and this is not a typo. So basically, this is exactly how I see it. And my reason for this is like, this is not mandatory. This is absolutely optional. And because of this, you don't take care until it's too late. Additionally, you can improve recovery experience because you kind of read internal state from the database directly to some point, and then you only read events starting from this point to the current point in time, which is much quicker, obviously, but they don't replace events in the sense that event journal is also used, if you remember the picture, on another side for the client. So events still have to be in the journal. It's less restrictive in the sense that you don't need to version it and so on, but it's more restrictive in the sense that it's kind of makes changing your internal structure, which you persist into the snapshot journal, much harder to change. So, and if it's not trivial, not trivial to serialize, then you kind of doomed. For this specific project, we just gave up. So we have 15 minutes recovery time. We don't care. I mean, people using CRM, Microsoft, and they still have good user experience compared to that. Yeah, so recovery goes hand in hand with let it crash philosophy of akka. But if you think about this, let it crash means if something goes wrong, your actor should die, and another one will be doing his job. But if the actor dies, if it's persistent actor, it will recover his state from the journal after he comes back. So let it crash a couple of hundred of times and see what the database will say to you. So it's actually, we only let actors die if it's not persistent actors. But as soon as you have non-persistent actors in your system, you have to think about what should happen with the data those non-persistent actors hold in the state if system crashes at this moment or if it's restarted. So basically, this means somebody else has to restart this actor and give him this piece of job again after the restart, which leads us to at least once delivery. It's kind of very common thing in akka, and yeah, sorry for what will come now. It's kind of a protocol which you need for at least once delivery. You have a message and a confirmation, which are commands in our event sourcing system. Those are events in our event sourcing system. This is a persistent actor. I hope you can read it. I cannot make it bigger, and that's actually exactly the point. You have to do a lot of stuff. Like if you receive the command, you need to transfer this to the event and modify your state. So transform to event modify state here. And then additionally, during state modification, you should deliver this message or confirm delivery depending on the kind of event you're getting in your actor. And during recovery, those two sum up, deliver and confirm delivery. And if there are deliveries which are not confirmed, then they will be reissued. Yeah, and the non-persistent actor is actually quite simple. So if he gets the message, he has to confirm it after the job is done. It's kind of straightforward if you think about this for a couple of days. But the whole point is like we had to send one message from one actor to another and one message back, and now it's a whole protocol. And all of them land in journal. It's kind of a, yeah, it gives you more possibilities, but at the same time it makes your actor structure so restrictive. You cannot just modify their relationship anymore, because they expect messages to be from one to another, and there is nobody in the middle, or at least you should not do this if you want your system to work correctly and actor to work together. Yeah. So actually very covered. So let's go to clients and views. I will now probably talk a little bit faster because I have a lot of things to show and less time. So we read from the journal. Every event which belongs to some user is tagged appropriately. I will skip this. Basically, we read this by the tag for this user, and the tag for this user is like somewhere deep beneath the surface. It's just an SQL which produces this query and then filters with like. And can you see the problem? The problem is here. So it's not indexable. So it's basically full text search over a couple of millions of events, which takes, on a good instance, dozens of seconds. So we modified the library, making it indexable, and that's an example how removing one single char can give you 4 orders of magnitude improvement. Okay. Number of events is another issue. As I said, we had a lot of events. Actually, all of the events which do not constitute to the event view land at the journal as well, because there is only single journal. So we had to filter events for the clients. So we basically had no use for the internal journal, which was the purpose in the beginning at this point. So we could as well have something else which would write into multiple tables. And I'm not talking yet about non-trivial use cases. For example, let's imagine we had a single user, but now this single user goes to vacation and another one needs to do the job for 2, which means we need to reassign some use case, some end customers from one user to another, but do this temporarily. But we already have all of those tags assigned to the events, and we already do know that this specific address belongs to this user. That's in journal, that's forever. Yeah, I will just skip it because it's corner case. But another good point, bug reports. We have a state in the client, we have a state in the backend, which are basically very similar. So if we had the bug reports from user, we could reproduce it from the backend and from the endpoint to exactly the same time. We could compare it, and we could easily find bugs. But having bug reports means we don't do sufficient testing. Obviously, yeah, who does? And partially reason for this would be that we needed, first of all, if you test actors, then it's hard, because actors you can only test actors observing side effects and internal state. If you need to test persistent actors, you need to additionally observe changes in the journal. And if you need to test persistent finite state machines, then you need to additionally observe changes in the behavior, which is kind of not very pleasant to do. Those are the reasons. And I will just give you some time to read this, because I really like it. It's brilliant. So we ended up having very rich domain model, which would do all of the stuff related to the events and commands and validation and internal state, and producing side effects, not applying them, but producing them. And we only left akka as a means of persistence and transport. Yeah, but still, sometimes you have no choice but to test what is an observable effect for the client. And for this, we found this guy, this gbehave, very, very useful. The next slides would be hard to read, but the intention, I will just explain blocks. So this is a description of the test. This is a test scenario. And we name some stuff here and we say, okay, this is what we do. This is a description, this is what we do, and this is specific for a single user of the system, and it describes commands which are issued related to this single user. And then we say, okay, then we must observe this change in the journal. And it was quite easy to read even for business people who are on this blue table I've shown you before. And it continues, like the second scenario, we do this stuff, and we expect only this to happen, and Y is in the blue head of this test. So those are end-to-end tests, which tracking changes in the journal or view as view from the client. Yeah, that's how we test now. And summary, the akka is great library, but it's not a framework. So just maybe to make some comparison, you can move your Earth between A and B with a bicycle and with a car. And depending upon where the A and where the B is, one or another would be better in each situation. So if you use akka as a framework, sorry for you. If you use it as a library, in very specific use cases, you will probably have a very great user experience. You will probably have great functionality implemented very fast and reliable. But don't try to solve kind of architectural problems with akka. That's not what it is. And another one, yeah, if you that's general for event source systems. If you doing event sourcing, be prepared that event source system won't only provide you with benefits usually associated to it, like having a history or current state of the system at any moment in the time, having the flexibility of building views for different clients and scale them as needed. Yes, which is actually secure as not event sourcing, but indeed. But this system will capture all of other changes you will have. So like changes in the code, changes in the business processes, changes in the third parties, bugs. So for example, you had a bug. Of course, not you had a bug. This junior developer made it 1 year ago. But now you have 100,000 events which shouldn't be in the journal. So, and you should not rewrite the journal. You put the handler for this in your code, and it stays forever. So I should say this was really a revelation. As I started to do the next project after this one, it was like, wait a second, I can just change it, and that's it? That's not thinkable in event source system. And that's it. That's actually everything I wanted to tell you. Thanks.
Thanks for the talk. And did you consider to ensure that you have snapshots for all your persistent data to reduce the number of migrations of your events?
Yeah, that's a possible solution. The problem is if you, for some reason, need to change your internal structure, or the structure of the implementing actor, in the way that it's not backward compatible to the snapshots you had before. The very easy solution to that is to just nuke the snapshot table, or at least remove every snapshots you had before for this specific actor, and then they will be rebuilt at the next start from events.
But there may be another idea to store all the snapshot, but to clear the old events, and maybe to artificially instantiate all persistent actors to make that new snapshot.
Yeah, the main point of event sourcing is not to rebuild the internal state. That's kind of a side effect which you need to do. The main point is that you have read views, kind of the CQRS goes hand in hand with event sourcing, and events are used to build views which are then used by salespeople, by mobile applications, whatever. And if you start to delete events, those views won't be consistent anymore. Or you start to create snapshots for the client and for the Excel and so on. And then you need to implement this reverse logic in the client, which is not trivial depending upon how many clients you have.
Okay, understood, thanks.
Did you have to do the queries through different entities? For example, find the entities that have name field matching certain criteria?
Totally. Basically, they are used for business analytics in the first place. So we try to avoid this for the mobile client because it's not scale. It doesn't scale. Luckily, we have this JSON structure which is readable, not writable, but readable, and we can do this. And yeah, it's kind of hard to work with this with MySQL. With Postgres, it would be much easier, but still we can do this, and we do this if needed. Binary format would be very inappropriate in this sense, so it would need you would require to build a client, basically a Scala client, to read the journal and to decode this binary format and to build whatever view you want. But having JSON allows just to query the journal directly. Was it your question?
Yeah, did you do these queries directly in the journal table or build some kind of view?
It depends. So it depends on the complexity of the logic which needs to be executed. So in absolute majority of the cases, we really need to develop a logic for that, because it's not trivial to accumulate kind of text you can read with a query from the JSON field in MySQL. So it's kind of easier to do in Scala client or Java client,
Okay, thank you.
whatever client.
Can I ask you a question?
Sure. We have time? Or is there another question?
Yeah, I'd like to ask you. Thank you so much for great talk. So, question is, do you have any suggestions when you should just stop and not use CQRS and go for other solutions like good old CRUD? I mean, how to distinguish when it's time to stop?
Yeah, great question. Thank you very much. The suggestion is just try, the CQRS is very infectious. So it will infect the code base you have. And because of this, if you start to build CQRS system, try to build really as less as possible. Try to contain it to the use case which is really good for the CQRS. Not every use case is good for that. So some cases are justified, some don't, some not. So if you just limit CQRS to the use cases where it's good for, then you will have much less troubles with that.
So how did you encounter the situation of split brains, and how do you resolve them in context of the akka-persistence?
Yeah, totally. Basically, not in context of akka-persistence, just because, as I said, we don't care. We don't care about clustering and so on. We have one huge instance which is able to serve all clients writing. We have a couple of huge of views which serving all of the clients reading, and we don't do anything in this code, just reading and combining stuff. Where we have split brains is on the third-party communication, and the very unfortunate fact is that like if you have a wishful thinking, then you say, okay, I just fire and forget this message to this actor, and this actor will eventually put it through to the CRM or whatever third-party service, just because it's supposed to work at some moment. And when it's not, then you have a problem, because you don't have any way to propagate it back, this failure, and it stays in your system forever. Sometimes it's possible to mitigate this using manual compensation events or something, but yeah, that happens.
Thank you.
I guess we over time? No? Yes. No, still 10 seconds for the last question. Okay, thank you very much.